Okay, good morning everyone. Thank you for joining today. So what I'm going to be talking about is how can you give agents human expert verified skills. Now the reason I'm going to talk about that is because in science, the quality of your output is quite important, especially because if you're developing something and you're not an expert in the domain, LLMs can easily trick you. So what we want to help create is the ability to create workflows, agentic workflows, and have them verified by scientists so that you can trust that output, essentially, as you start chaining it together. Because you can imagine at scale, if these agents start having slightly erroneous outputs that aren't then checked, the whole society can go in a rather unfortunate direction. So how do you give agents expert verified scientific skills? Now, a key point here is that within different domains, the people who have the knowledge to verify this often have a limited time. So you want to create an experience that makes it easy for scientists to take part and give input into how your agents are performing. Now, to give you a context of how we've approached this, I'll first start by talking a little bit about where we're coming from. So about 3 years ago, just about 3 years ago, when we saw the convergence of what's happening with the latest AI capabilities, this was a bit before the ChatGPT release, when we started looking at this, and within what was possible with programmatic incentives, what was being talked about in DeSci, and the opportunity in science, we saw that creating an open source environment for bringing together experts and having it be possible for them to provide their skills in such an ecosystem would be very powerful. So over the past 3 years, we've been mapping essentially what are different steps in this process of going from an idea to an outcome in the sciences and talking to scientists about how they try to solve this. And it's been a journey of really prototyping and understanding relative to the latest capabilities of LLMs, how far can they take us and what do we need to do in order to create an experience for scientists to contribute to. So we're very honored where, DeSci has really enabled us to do this on an unprecedented level because of the transparency and the values of, for example, the BioDAOs. So, many of you in this room have been giving us input in different stages of this journey, and it's really been essential for us to be able to validate rapidly that we're actually going in the right direction. And what's exciting now is that we've also been working with more traditional organizations, and just to speak to the bioagent opportunity, there's a realization in the broader scientific community now that the way things have been done in the past need to change. We also work with funders of science, and there's an increasing understanding that there's a need to set new funding mechanisms that can be run programmatically, and where agentic scientific swarms can play a really important role. So I think the world is now catching up in a sense with a lot of these pieces, so it's a great time to be building in the space. And so as a result of this, we are now in a position where we have an open source platform that lets you rapidly create these skills. Through the creation of that platform, we have already then catalyzed a multidisciplinary expert network. And we're now moving towards the next step of how you can layer a programmatic incentive system on top of this so that you can actually reward people for their contribution. Because any scientist in the room might know, some scientists are somewhat skeptical about giving over all their expertise to these automated systems. So we want to create an ecosystem where people are rewarded for doing so. And that's really one of the key things that we've been driving towards. As a side note, this is where we think a lot of the discourse around retroactive public goods funding is very exciting here. Deep funding is an initiative that I would check out that is currently focused on open source, but is now being extended to research. And these are the types of capabilities that will enable not just the experience of providing skills in this way, but also reward mechanisms. So let me just kind of dive into what do these skills look like. If any of you have used a kind of visual LLM coding flow, it might look familiar. But essentially, it lets you construct these pipelines and allow you to have a certain level of determinism on top of these probabilistic systems. Now, if you're not familiar with those terms, the key thing to keep in mind, LLMs, if you give them something, they will give you different types of output each time. So what we're trying to find is how do you balance the benefits of that in terms of the power of these systems with then needing some sort of consistency when you're running these. So the way that we typically set this up is that you'll have an input point, and this will go into a prompt with some guidance on how to handle that input. This will give you a response. And you can then extend this in multiple different ways. For example, you could send that response to an external evaluation agent. Any of you building agentic systems here, you can build integrations into these as well. I can speak to that further later, or if you have any questions, let me know. But you can also have human evaluation steps. So basically sending this out for human evaluation and then getting context back that then goes into a refinement step. and then you get the finalized response, and this is given to an output. Now, this is a very simple example, but the core thing that I want to speak to the developers in the room is that basically you have an input and an output, and these become your endpoints that you can use as a tool call for your agents, essentially. Now, another important point is that with these skills, they're basically versioned, so that every time they're running, you know what skill you ran and the output for that. So you build up also an interesting benchmarking database, basically, for that verification of how well it's performing. So that's just the kind of skill structure in a nutshell. So now I want to show you what this actually looks like in practice. So if you log into the platform, you basically come in, you have a profile, and you can create your skills. These look like cards. And what I just showed you behind this, you basically have one of these flows with an input and an output. And these are very versatile, essentially. So I'll show you an abstract analysis skill. So this was done for a test run for a prominent foundation that's working on Parkinson's disease. And essentially, it's a skill to evaluate abstracts as to whether they should be used for deeper dive analysis in terms of identifying relevant literature for a specific gene type in scientific research to cure Parkinson's. And so you set up the skill, as I showed you, and then you can run it. And on I quite like this visualization, because here you see all these inputs that it's now going to be analyzing, and then it will run this for you, and it's generating a table, essentially. So this gives you a way to set up an environment where if you're feeding in some abstracts or literature that you want analyzed, and you want the output to be, for example, in a tabular format, this gives you a way to do that. And everything is in Markdown, so you can actually present that to your, your collaborator scientists for verification and so on. And once you're done, you basically have your output. And just as an example here, as it's in Markdown, you can literally copy and paste that if you so wish, and put it into something like Google Sheets to share. So it's really like, there's a lot of pragmatism in this, where you're basically setting up ways to run these flows, get output evaluated, and be able to refine it that way. Again, as there's a lot of developers in the room, you don't need to plug it into Google Sheets. It can be an API call to get that and put it wherever you want it, or pass it on to your agent for further consideration in whatever pipelines you have available. Another example is then, so with the abstracts that I showed you, that was a first step to evaluate should that abstract actually be analyzed deeper. And so this is just an example that then you could take those, the kind of, once you get a yes/no on whether you want to go further with that abstract, that can be handed off to a deep dive analysis, and then a similar type of structure can be done, but answering different, more specific questions where you know that you want to analyze the full text of those papers. And again, it will generate a output. And here it's a little bit compressed, but as you can see, again, easy to copy out. And now it's done a deep dive analysis of those papers and the particular details that were relevant. And so this gives you a way to kind of get a sense of how it brings what is happening, let's say, often behind the scenes in the coding environment and so on. It gives you a way to kind of bring scientists into that universe without necessarily needing to onboard them into too much complex new technologies, essentially. And we've seen this resonates very strongly. Now, what I want to show you next is going a little bit, let's say, more creative, where the other thing that we've been working on is we collaborated with the Foresight Institute, which is a great nonprofit based in SF that brings together communities around frontier technology. They have an initiative called Tech Trees, which is around mapping pathways to solving complex problems, often within things like neurotech, longevity. Those are two of their focus areas, also molecular machines. And so what we worked with them on is how can you actually automate the creation of these roadmaps that then could allow for an environment to get human feedback on what are the right pathways, and those could then initiate agentic swarms to go help fill out, the research that's necessary to make progress towards that, accelerating the pathway to those outcomes. So this is just an example of how that can be done. This is for creating a tech tree for achieving composite learning, so decentralized training of machine learning, and doing so on not just the latest GPUs, but a broader set of hardware. There's some guidance principles up there at the top for how to do so, and this essentially creates then you'll see here in a second, a more mind map style tech tree that is literally taking that goal, breaking it down into different technologies that you might need to look at, the different challenges to achieve those technologies, and the new technology solutions that might help you overcome those challenges, and does so, again, in a way that you can then share with experts to get input on, is this right or is it not? So kind of you can call BS quickly on where it might be hallucinated or where there might actually be other ways that are better. So it's creating these high bandwidth communication methods between your agents and scientists. Now, the follow-on piece is that, of course, human input is great, but you can also now use agents to verify. So this gives an example of how you can do so. This is kind of this idea of using an external agent. So if we take one of these nodes, for example, this is then given a summary, and this is fully generated by the LLM, so you might say, hey, is this right or not? So we created an integration with PaperQA, which is an agentic system from FutureHouse, and here you can then basically take that node as input. It translates it into core series of literature questions that you want asked, and it's asking that of the literature, and then basically giving you a response with citations from the papers that it's checked. And so in this case, you're able to basically map a domain, enrich that domain, have human input, check it with external agentic workflows in a matter of minutes. It's pretty cool, and it means that you can create this high bandwidth communication process with the experts. And so I think those were the main things I wanted to show. Now, one thing that I want to mention that I don't have a demo of here, but if you're interested, come talk to me, is that to the theme of knowledge graphs, I'll speak to it at the end of my presentation briefly, but you can also have as an input a JSON, like basically JSON as input. So if you have JSON coming out of a knowledge graph, you can put that into your flow, and you can play with different analysis pipelines on top of that. So it's just to say, it doesn't have to be text as input. This is the beauty of LLMs as well, is that there's diversity of how you can transform between different formats. For example, we have one skill that a group has been starting to test where it's checking for the reproducibility of research, where they basically can first do the evaluation in more natural language, but then take the output and translate it into a JSON format that they then take further. So that's just to say you're not purely stuck to kind of traditional text as input and output. So what does this mean? Well, it means that you have these verifiable skills that you can co-develop with scientists and get to a place of comfort that you know they'll be operating at the right level. And then you can empower your agents with these. We have an initial ELIZA plugin prototype. We'll probably need to update that for V2. Sean could probably give me insight into how big a lift that is. But essentially, this means that your ELIZA agent can call these skills as tools. And I think Sean mentioned yesterday, to the millions of agents that we want running, that's what, you'll basically have this at scale, and it can run this expertise at scale. And that's a key theme of ours, is basically how can you scale expertise? This is a great way to do so. So overall, a last piece that I want to mention is that we're working with a broader set of stakeholders in terms of the community. What's exciting, we actually now are also on the pathway to onboarding more state-level R&D agencies, like universities. This is getting, the broader ecosystem of this is now growing quite rapidly, because I think the appreciation of the need for these capabilities is growing as well. So the way that we're building is also with a view to creating composable environments, so that, for example, these tech trees can identify dependencies or challenges that need to be addressed, and this can then identify the research and experiments that need to be addressed in an open source environment where data is coming out of each of these layers. They can go into multiple model training mechanisms that then improves the overall system. And so that's why we're very excited about open source as being kind of the underlying layer of all this to enable this type of composability and interoperability across the user bases that we see. And to the programmatic incentive side, it means that we have pathways to also looking at actually then, let's say you create this tech tree, being able to say, I want to allocate funding to this problem, and then you have others who can join to that and pool funding there in a programmatic environment where you have dependency graphs where all of this can flow back to the initiatives that have helped solve it. So this is just to briefly speak to the retroactive piece of this, where by doing this in this way, you foster an environment where you can have individual expertise aggregated towards solving societally beneficial outcomes, and have then the contribution and dependency graph that you can fund retroactively to accelerate everything, essentially. And so one little tease is that in the spirit of this, and in the spirit of verification, you'll be hearing from Jay from BARD in a second, but we're also setting up a bit of an experiment, which is essentially a decentralized social gamified experiments for verifying the outputs of systems, where you'll have different types of knowledge graphs or world models, so to speak, generating outputs that then go into different hypothesis generators. And we're likely going to be working with, for example, AT protocol, which is a decentralized social protocol, where you can log in and you can basically engage with the output on an ongoing basis to give feedback into how well the system is performing. So our whole goal is basically to create an at-scale environment that allows you to verify the abilities of these systems, have the ability to reward those that contribute to doing so, and accelerating everything along the way. So this is a tease of it. We can announce further details very shortly, but it will create an environment where you can basically assess the performance of different systems, and through that assessment actually provide training data to improve the overall systems along decentralized principles. So in summary, if any of these things sound interesting to your initiatives, if you're interested in tapping into the multidisciplinary expert network, if you're interested in having a library of verified scientific skills, and as we bring in the programmatic incentive system, this sounds interesting to you, please get in touch with me. This is a QR code. It has a type form. You can enter your details there. I've also asked Eric to share the direct link I believe on the YouTube stream or in the Telegram group. If you share your details there and what you want to do with the project, then we can take the conversation and look at how we can bring you on board. So yeah, that's, I think, all that I wanted to share at the moment. I'll be around also. I believe there's a lunch after this, so I'll be around for that. So feel free to approach me if you have any questions. And yeah, thank you very much for listening.
Any questions?
Yes. Hello. Yeah. Hi. I had a question going back to, you had one slide where it was showing how an eval system would go back in loop. But my question is broadly, I would love to just hear about your experience with working with eval systems throughout your work.
I mean, so yeah, our focus has been very much on what I would say is we've been looking at the manual side of things very closely. So putting literally Google Sheets in front of scientists, to that level of manual. So I think at this point, we've mostly been looking at kind of setting up that loop so that we can get very specific answers from specific scientists rather than fully automated processes at this stage. However, if you're interested in, the gold standard from my perspective on a lot of agentic science side is what the approaches that Future House take for the development of their agentic systems. So that's where I would kind of point the direction on in terms of how they've benchmarked their agentic processes. And what we're trying to do is basically kind of move towards the hybrid of those two things. So yeah, that would be my kind of slightly non-answer, but hopefully it gives some input.
Appreciate it.
Oh, sorry. You have a question.
Any other questions? But I'll add that I think last week OpenAI came out with it's called Paper Bench, where very interesting paper on evaluations and working with the researchers behind papers to create a rubric. But
yeah, and I think what I'd say is that with a lot of the work that's being done today, what we want to do is bring that out into the open. So I think the interesting thing with a lot of the research, there might be outputs that come at the end of the process to some degree in a paper or a model eval or whatever it might be. I think what we want to do is create a live dynamic environment for these discussions to be happening on an ongoing basis that is open to everyone to see. Because it's really I think one of the tricky things at the moment is kind of when you see these systems being developed is just there might be a huge variety of different ways that the outcomes were achieved. I think with Google co-scientists, there was a lot of expert human-in-the-loop feedback processes and those things. They had amazing results, but it's kind of, we want to make that discussion and really understand, are there certain fields where it's actually performing a lot better? Where is the diversity of these systems' capabilities? What is the state across different scientific domains, rather than kind of hype statements? So I think I think that's somewhat tying both of your comments. It's kind of how can we bring that to a kind of dynamic environment? And I think this community is a great place to do so, so that people have open discussions of what is and isn't working, basically. Just to riff on that. Sorry, there's been a question in the back from the get-go. So.
Thank you so much. I'm a scientist, so I've learned a lot throughout these sessions. My first question comes to, in order to maintain this dynamism, do you guys have a system in place to check for any papers that have been retracted so that the knowledge always stays the same? And then for your human scientific experts, I'm from Cameroon, West Africa, and one thing we've always noticed is that a lot of the scientists chosen for certain things are from the global north. So a lot of the expertise from the global south, or even, for example, Asia, like where they are the big experts for dengue, but they are not the ones being chosen to be given their expertise on dengue. So have you thought about including people not just from the global north, but also from the global south?
Yeah, absolutely. And that actually kind of dovetails to what I wanted to mention, or what I mentioned there, is that we want to create like an open environment that encourages, as many voices as possible, rather than these kind of closed conversations that often exactly suffer from that problem. And I think this extends also to, principles of the use of data. There's like the FAIR principles, there's the CARE principles. I think there's a lot of additional layers that we hope to encourage in a much more open conversation. And the work that we do is very much seeking to speak to basically contributors from around the world, essentially. So it's definitely a central part of what we're trying to do by building all of this in the open as much as possible, and also making the output maximally a public good so that everyone can build on that resource, essentially. So you both benefit from the diversity of input and that it can be used by builders around the world as well. So this is, I think, a key theme of building in an open and maximally kind of permissionless environment. And was there a second question? The retracted papers. Yes, so I think it's a really important point and quite an interesting one. I had this conversation on Monday as well, because it's not just retracted papers, it's also just papers themselves, because many make claims, and the degree to which papers are reproducible, I think there's the yes, no error initiative was one that kind of spoke to this within the, let's say, Web3 community, but I think basically, ensuring that there are ways, I think there was a question about knowledge graphs and, if you have erroneous input into the knowledge graph. I think keeping track of these things is going to be very important. Now, our approach to that, a key element is the audit trails of every run. Basically, you will know exactly what inputs are there. So trying to plug into basically databases that keep track of, whether there's something to the DOI that allows us to say, oh, this has actually been retracted. What we have wanted to encourage is that you then literally have an audit trail so that if that triggers an effect, you could see, oh, this decision was influenced by a system that reviewed these pieces of information, one of which is no longer valid. And that could be triggered by a flag that this has been retracted, or it might be that there's an evaluation system that goes through the papers and actually starts applying additional metadata as to whether this is reproducible or not. So these audit trails play a central role for why we've established them for exactly being able to go back and update any decisions that were made based on what has then been found to be erroneous data, essentially.
Great talk, Martin. Always great to hear you present. I had also more of a philosophical question. Along the lines of, so as you say, you're starting to speak to R&D level funding agencies and governments and universities. And as you move towards this potential retroactive reward system, and this will be based on basically the DAG, or the knowledge graph generated, how have you discussed how this is determined? Because assumingly this is based on citation, and already citations are a problem in terms of people spiking their own self-citation and everything. So have they discussed about how this might be remedied?
So, the first thing I would say is that citation graphs alone is probably not going to do it. And the second point is that it is definitely an area, to caveat, is definitely an area of open research of how to best do this. I would actually say even before getting to that point, I'm happy that they're getting to the point of self-realization that you're going to need new funding mechanisms to move faster. So I'd say right now in the, let's say, on-ramp to this new world, we're mostly at the, we're going to have to fund things faster point, rather than the details of exactly how that gets done. But this is where, for example, I know even within, have you been following the deep funding project? Okay, so that's a great one to look at because they've initially been looking at ways to evaluate open source dependency graphs in order to do retroactive funding based on that. And they're now moving over to citation graphs. And there are two parallel initiatives there on how to assess that. So what I would say is that there's likely going to be a variety of different experimental approaches that will be taken. And I think the goal will be to evaluate, like to do smaller scale experiments and see how does this work. And also, I think the great thing now is that with these new mechanisms, you don't just generate the citation graph, but also contributor graphs of input into these processes. That means you get new sources that could be taken into account. And so I would say you'll have a richer data set, basically, that you can consider when you're looking at the retroactive side. But the beauty is that it encourages them to do things as maximally transparent and open as possible. So I think there's some virtuous cycles that can be initiated. But there is going to be a phase of experimentation necessary to refine how exactly to do that. But to that experimentation, I'm a big fan of diversity, basically, in terms of like, there's not going to be one size fits all, but rather set up an environment where you could have competing systems, and then you will find different incentives for optimizing how that works. So yeah, that's a big theme for us, is kind of how do you create an ecosystem where you can set up these experiments, share the know-how, and find the best practices, and then optimize and iterate from there, essentially. But yeah, I would definitely check out Deep Funding as probably like, they're also doing a lot of their work in public around essentially they create this weighting system and then they do a random sample of judges, and then this is like there's a scoring system tied to that. So that's a very concrete example to look at.
All righty, we're going to have this one be the last question.
Okay.
I have a question about FAIR.
About, sorry?
FAIR. FAIR. FAIR ecosystem.
Oh, fair. Yeah, sorry. Yeah.
Yeah, so I understand about citations and I understand about data sets. And how about data level? So usually if you have data set, sometimes they have persistent identifiers like DeSci, but in most of cases, it's not available. So it's not sustainable, it's not fair. And I mean, the graph is moving, right? And you have column names as variables, so you can do something with it, but as soon as it's not sustainable, you have to do something, right? So you're assigning your own identifiers created by infrastructure, or how you do that?
Yeah, so we haven't, like at this stage, we haven't gotten to the point to answer that question. I would say is this, we're at this stage where we've mostly been focused on setting up these pipelines and evaluating just that the output is good enough, to put it that way. So we will be looking to exactly have those conversations of how to best now publish that, essentially. And so I think Eric from FAIR was at an open science event that with a lot of people looking at the metadata side. So our goal will be talking to those experts on, okay, we're creating this new artifact. How do we now best make it available? So yes, it's an open question, but we are already speaking to the people, essentially, that we want to speak to make that optimal, essentially. Yeah.
And a great point to that is the use of decentralized identifiers wherever we can. A lot of
100%.
stuff with POIs, a lot of stuff with IPTs,
Yeah.
continuing to build out some of those frameworks.
And the event in Denver was hosted by John working at DeSci Nodes. And,
Exactly.
they've been carrying the flag on a lot of those things.